Thank you. Thank you all. Thank you, Paul, for being for accepting to be our speaker today. Um, Paul Bacoup for this for today conference in the frame of the cycle of lectures, dialogues between past and present, the materials, construction techniques, and social identity through the centuries, from the prehistory to the pre-industrial era in the Balkans and Eastern Mediterranean. Is a doctor of the University Paris 1, Panthéon-Sorbonne. I had the pleasure to accompany him for his PhD together with Haris Prokopiou. So we are both very pleased to have him today on the screen. He is now a postdoctoral researcher at Louvain, at the group Aegis of the University of Louvain, and a specialist in Aegean and Balkan prehistory, archaeologist, specialist of architecture and xylology. His research focuses on wood as material in general, but more importantly as a construction material, and it is with this from this perspective that he will speak today in our meetings about the building traditions with wood and earth in the Southern Balkans in the 5th millennium BC. Before letting him take the microphone, I would like to remind that in the frame of his current research, he extends also his work on the use of wood in the Aegean Balkan region, also in later periods, including all the Bronze Age until the end of the Bronze Age, and that he's also interested not only in the techniques but on the social and economic framework in which the building activities take place and the management of wood resources. So there are plenty of topics that could be open to discussion at the end of this very interesting lecture that we expect. Thank you, Paul. The floor is yours.
Thank you very much. I'm going to try to share my screen first, if it is possible to allow me to do it, please. Oh, perfect. Thank you very much. And first of all, I want to say thank you to Dr. Zoe Tsersoni and Dr. Caterina Rizzulli for this invitation that I'm very, very pleased to answer. And I'm very honored to speak in this web conference, especially knowing the other persons who are speaking in this web conference. So yeah, my discussion today will be about building traditions with wood and earth in the Southern Balkans during the 5th millennium BC. And actually, I have to confess now that I will mostly speak about wood in this earthen architecture in the South Balkans. The results that I'm going to speak about is I'm taking it about my PhD thesis that I defend in 2022 in the University of Paris 1 under the supervision of Professor Haris Prokopiou and Dr. Zoe Tsersoni, which was focused on timber. First, I will present the context, then the wooden techniques from acquisition to joinery that I can try to restitute during my PhD thesis. And then I would like to present you two study cases about experimental archaeology and how this method can help us to go further in social comprehension and to correct some of our technical hypotheses. So I will try to go quite quick on all of that to stay dynamic and to have question and discussion at the end, which I am very interested in, to have your feedback. So first of all, about the study context and the methodology. The geographical context of this study extends from the Danube Plain in the north to the Greek Macedonia in the south. Comparisons were also made in the border regions, as in Serbia, in Turkey, and more southly in regions of Greece. The period studied corresponds to the first 3 quarters of the 5th millennium, from 5000 to 4250 BC. The geographical area under study is marked by highly variable topography, which played a significant role in climate and the environment in which human societies develop. These high reliefs, together with the Danube, supply water to large plains and valleys. The beginning of the 5th millennium is characterized by a second climatic optimum. Temperatures rise until they reach today's levels, then exceed them. Generally speaking, plant diversity was at its highest in the 5th millennium BC. However, during this millennium, Neolithic population began to modify their forest environment in this region through their agropastoral practices. It is marked by the opening up of the forest cover and the development of cultivated species, which have a very big importance in wood availabilities for this period. The corpus that I studied correspond to architectural material from 3 sites, 2 in northern Bulgaria and 1 in northern Greece. Observations made on this material were then cross-referenced with those made on other sites in literature. First, the site of Dikilitash is located in eastern Macedonia, near the modern town of Kavala. The architectural material studied on this site correspond to the remains of 2 buildings, the House 3 and House 4. The tell site of Hotnitsa is located in the Veliko Tarnovo region of northern Bulgaria. The architectural remains there studied corresponds to the remains of 4 buildings, unburned buildings, actually, as you can see on the picture. And last but not least, the site of Petko-Karavelovo is located in the same region, quite close to Hotnitsa site. The architectural material studied on this site corresponds to the remains of 10 buildings, unburnt and burnt. It is in total something about 3,000 imprints and 1,000 wooden pieces that I studied for the 3 sites. The interdisciplinary method that I tried to set up combines technology and paleobotanical studies. It is also based on an experimental approach and ethnographic comparison when these allow us to test certain hypotheses proposed by studies of archaeological material. This method allowed us to study all wooden pieces according to the same criteria, whether they were preserved in positive or negative forms. It takes into account the specificities of each type of conservation known in archaeology, but also opens up a dialogue between them. About the study context, the majority of known 5th millennium settlements are tells although a few flat sites have also been discovered. There are also a few cave dwellings and pile dwellings. This period saw a densification of settlements compared to the previous periods, with the emergence of numerous sites throughout the region. Habitation sites are generally protected or protectable areas on the banks of rivers or marshes. Some pre-existing sites migrate to this type of locations. They are regularly surrounded by a protective device such as a wide ditch, one or more wooden palisades, or even stone walls. The interior of the sites is generally orderly and densely built. The buildings are of two architectural types, ovoid buildings and quadrangular buildings with 1 to 3 rooms. Some of these buildings have a first room forming an open vestibules, as you can see on the building of Petco-Caravellovo on the right of the screen. Building material were mainly wood and earth. A few use of stone are attested, for example, as post wedges and as wall bases. The main construction techniques for walls and partition is daub. The daub techniques involves applying a layer of building earth against a load-bearing wooden frame. Daub technique is used to build the walls of buildings in all contexts, including caves and dwelling piles. Finally, despite no archaeological discoveries, roofs are generally restricted as two-sloped and roofing material are unknown. The assumption that roofs were built using the double slope morphology is based mainly on comparison with model houses and is considered more appropriate to the climate and the region studied. Now I will focus on techniques for acquiring and using wood in architecture. And first, to determine this type of techniques, I want to go further in what kind of wood, what species of wood was used. If we limited ourselves to species used with certainty in construction, an already wide choice emerges. At least 15 species have been identified, including 4 conifers and 11 deciduous species. But how the ancient builder decided to use this wood, what kind of choice they did? There are choices shared by all the communities in this region for the 5th millennium. Although riparian species are abundant in the vicinities of the sites, this species seems to have been excluded from the construction sector. The choice of timber seems to be guided by the properties of the species in relation to their future function in the buildings, as we were able to demonstrate when studying the material from Petco-Caravellovo. One hypothesis put forward for certain sites on piles, notably Dispilio, based on juniper's ability to resist rotting in contact of water, is that the chemical characteristic of the species guided the builder's choices. However, based on data from other lake sites, oak is preferred for construction in wet conditions, and its use is also justified by its rot-resistant properties. It therefore seems that the technical choice linked to the rot resistance characteristic of species was initially guided by the availability of the species. Indeed, at Dispilio, the presence of juniper at short distances from the site than oak seems to have guided its selection, as much, if not more, than its ability to resist water. Studies at Petco-Caravellovo emphasized that selection seems to be more closely linked to availability on the one hand and to the physical characteristic of the wood pieces on the other hand, flexibility, mechanical strength, or feasibility. For certain architectural function, it seems that this aspect is the most important, even if it was necessary to source wood over long distances. Lastly, morphometric studies of the pieces of wood used in construction at Diclita, Srotnica, and Petko-Caravellovo show the use of pieces with reduced diameter and width, only on rare occasions exceeding 15 centimeters. Bibliographical data on building earth fragments from other Aegean Balkan sites also point in these directions. Our experimental work has shown that this diameter must be considered in relation to felling times, which are exponential and can thus become almost 3 times longer when trees exceeded 14 or 15 centimeters in diameter. About the chaîne opératoire of timber elements. It comprises 4 steps. 4 big steps: felling, limbing, bucking, which are the 3 steps for wood acquisition, and finally shaping, if necessary. In order to understand the type of felling practiced, we needed to study the piece of wood, and more specifically, those that are pointed. 3 types of felling can be identified, all of which are likely to have been used in our study region. Felling by double opposite cuts, as you can see here, one of which is deeper, serving as a hinge. A single cut serving as a single hinge on the wall or on the fall face after proof on the opposite face. And 3, cutting the tree around its entire circumferences. The 2 first have the advantage of being able to control the direction in which the tree falls. The first is more suitable for large trees, unlike the second. The third does not allow you to control the direction of the tree falls, but it does offer the possibility of obtaining a point directly after felling. The limbing is an activity that can be performed once the trunks have been brought back to the site, if we follow the interpretation proposed for this pilio, for example. In reality, it is likely that only a small part of this activity was carried out on site. Studies carried out at other European sites suggest that delimbing is carried out at the felling site. Experimental work indicates that delimbing can be carried out by hand for the small branches or with stone tools. Blows with stone tools are generally applied to one side of the branch only, then the last fibers are removed by hand. Bucking is probably first carried out at the felling site. The length of the piece of wood needed for construction is anticipated to some extent to facilitate transport. Nonetheless, it is highly likely that cutting was also carried out on site to adapt a piece of wood to its architectural position. About shaping timber. The most known technique that we can restitute is splitting pieces of wood. It is attested at numerous Aegean Balkan sites. Experiments and ethnographic studies suggest that the tools used are mainly wooden hammers and wedges made of antler or wood again. Stone tools may also be used to begin the crack. There are 2 types of splitting, radial and tangential. Experimental studies have shown that tangential splitting is more difficult than radial splitting, and the archaeological evidence at Dispilio or Anargheri Enya Vita seem to support this view, as very few boards made by tangential splitting have been found compared with radial one. Technical advantages of splitting pieces of wood are therefore threefold. Several pieces of wood can be obtained in a single log. The piece of wood offers greater mechanical strength and assembly is facilitated. Then splitting also enables the wood to dry more quickly. If we take the idea of squaring with tools and keeping the earth of the wood in the central part of the piece of wood, we don't have actually evidences for this kind of techniques in our study area. To obtain a piece of wood with a pseudo-quadrangular cross-section, it seemed that actually they didn't use tangential splitting, but they preferred to use radial splitting, obtaining some quarter of log. Then they removed the two edges, actually, the earth one and the bulk one, to obtain some pieces which have a pseudo-quadrangular cross section. It is something that is quite common actually in wood construction during the Neolithic around Europe, especially if we take this kind of example about wells for the early Neolithic in Central Europe. Last, sharpening is difficult to identify when the wood pieces are not preserved. In our study area, 3 types of sharpening appear to be known. The double-beveled, wedge-shaped. It is shaped by working on 2 opposite sides of the piece of wood. The single bevel, called kiezel-shaped, it is shaped by working on only one side of the piece of wood, and the cylindrical point shaped like a pencil by working around the entire perimeter of the workpiece. These 3 types of pointing are largely influenced by the type of felling or bucking of the piece of wood. For example, at Analgheri Egnavita, almost 20% of the pointed or beveled piece of wood have a truncated end, which surely correspond to the part of the fiber not cut during felling or bucking. These pieces were not subsequently reworked before being used. However, it seems that the ends are regularly reworked, based in particular on the angles of attacks that are too small to be those left by axes at the time of felling or bucking, according to our experimental studies. It is also a way to know if they were reworked with axes or adzes, because adzes allowed us to obtain very small angle to attack the wood. If we go now about how to join the different pieces of wood during the 5th millennium in our region. Several types of joints are known. Here we will divide joints into 2 categories, simple joints and work joints. In the case of work joints, the wood pieces are modified. Experimental work as well as ethnographic surveys show that these shaping operations are generally starting with rather large tools, axe or adze, then very quickly with more precise tools, stone chisel, bones or antler chisel. It is also possible to complete the shaping of certain assembly using fire. A certain number of these assemblies, particularly the simple ones, need to be anticipated much earlier in the chaîne opératoire, often as early as the bucking or even felling trees. The felling stage. There are 3 types of simple joints. We know interweaving pieces of wood. The most eloquent example is found in the making of wattle frame. Pieces of wood are deformed to force them into the position desired by the builder. Then, tendency of the wood to return to its original morphology enables the assembly to be self-clamping. We know lashing, the use of plant or animal material ropes to join several pieces of wood together. And we know also the use of natural forks. 2 types of worked joints are known. Bridle joints, the reproduction of a natural fork in a piece of wood by allowing out a notch in one of its ends, and mortise and tenon joint. This involves a thinned piece of wood, the tenon, which penetrates a cavity, the mortises, cut into another piece of wood. We have to add a third technique which allows to solidify the previous joints, pegging. It concerns a wooden frame discovered at Prodromos II in Thessaly, attributed to the end of the 7th millennium BC. This is the only evidence of this technique in the Aegean Balkans Neolithic, which is the subject of much debate. Perhaps this piece of wood were used as keys to prevent the tenon from going out. This technique is well known for the wooden frame of early Neolithic wealth in Central Europe, for example. As techniques to build walls, for our study period, we have identified 4 timber frames to build walls. We know the wattle frame. This can be very tightly woven with rods glued together, or looser with a space of several centimeters between each rod. The installation of vertical posts that are more or less parallel to each other. These posts are held in place by horizontal piece of wood. This requires the use of lashing to connect the cross pieces to the post found in the ground. But this type of frame is rarely combined with foundation trenches. Finally, the third one is the use of reeds or small wooden sticks arranged vertically and held in place by a plant rope or by a reed arranged perpendicular to the previous ones. And finally, the fourth was unearthed in the region and was highlighted by our study at Postdoctoral, the construction of a double wooden facings. For the floor, floor built from timber can be divided into 2 categories: full wood floor and earth floor with timber frames. The study of Rotnica floors has enabled us to identify 3 construction patterns. Using floorboards as long as the width of the room, resting on a reduced number of joists. The use of floorboards of varying length, resting on a greater number of joists and therefore less widely spaced. And the use of floorboards of precise length so that they rest on a joist along one wall and another joist approximately in the center of the room. For the earth floor with timber frame, it follows a different logic. The wooden pieces are no longer intended to form the floor surface. As a result, less care needs to be taken with the wooden pieces forming the surface. Such floors are common and have been tested at several sites in our region since the 5th millennium. The vegetal layer rests on joists that are sometimes resting also on binders. For the roof framing, little is known about roof framing. It is generally accepted that the roof of building in the Balkan area in the Neolithic period were in the form of 2 sloped gables, particularly based on comparison with house model. The layout of foundation pits and post hole can also provide clues. But the reconstruction of roof morphology, flat or 2-sloped, also requires the study of the other material. Where wood has not been preserved, building earth provides clues that may be reliable, but require an in-depth study. For example, the study of the building clay of Dialogues and Postdoctoral has enabled us to propose well-founded reconstruction of flat roof for all or part of building, especially the house 3 of Dialogues. Now that I present you an overview of the wooden techniques that I was able to reconstruct for this 5th millennium BC in the Aegean Balkan area, I wanted to speak about two cases studies that about experimental archaeology. How experimental archaeology can be a way to approach social interaction, and how it can be a way to correct archaeological hypotheses, especially technical one. The first case of studies that I wanted to speak, it is how can we approach social interaction involved in the transmission of knowledge by experimental archaeology. To try to expose you my thought, I have to speak a little bit about the experiment itself. It was an experiment which wanted to explore all the steps to reconstruct the chain opératoire involved in the construction of a building dating to the 5th millennium BC, from tree filling to the roofing stage. But the idea was not only to reconstruct the technological or the techniques, it was also to reconstruct, as the chain opératoire involved, to reconstruct also the social and the economic aspects of these steps. Each step of the chaîne opératoire was experimented based on several protocol-based experiments and several didactic tests. To try to approach this social aspect of wood technology, I try to put an experience level scale, a skill level scale, in which all the individuals who took part of the experiment has to auto-evaluate themselves in 4 categories. At the end of each step, they had to complete a questionnaire about, of course, how long the step took, but also how they felt, how it was difficult, how they learned to do the step, how they learned to practice with the tools that they never used, especially for the novice ones. Of course, it was possible to have an interest on the importance of skill and experience, but it was not our point. Our point was to approach cognitive intuition, task distribution, anticipation, and planning during the chaîne opératoire. I would like to take this example as a first one. For example, when we arrived in the wood to cut the 12 oak trees, I just showed to the two to the 2 persons who made the experimentation, the different trees. And I said, okay, we have to cut them. There were trees from 9 centimeter diameter to 26 centimeter diameter. But it was very interesting because I didn't guide how to do it and who do it in the first time. What was very interesting is that when the tree was above 15 centimeter diameter, they always chose to cut it by 2. When the tree was under 15 centimeter diameter, they took 1 tree for 1 person. It was something that they have anticipation on the time that the step will take and on the difficulties that they will have with pain in the body, for example. Something very interesting, each time that the tree was under 20 centimeter, they worked on their knees. When it was above these 20 centimeters, they decided to work on their feet. Another thing, without guiding them, when they cut the trees, when the trees were above 10 centimeter, no, under 10 centimeter diameter, they cut it with the single knot type of felling. When it was above 15 centimeters, they decided to cut it with a double notch felling techniques. Between 10 and 15 centimeters, but it's more approximate for this one, they cut it with this pencil type of cutting. Another way that it was possible for me, another aspect what was possible for me to observe, really as an observer of the experiment at this moment, was not only to compare the result of individual with varying expertise, but it was to observe the social interaction between them. It was to observe the processes of knowledge and skill transmission. When I decided to put this experiment to do this experiment, I asked to some classes, scholar classes to come, young people around 10 years old. And it was very interesting to see how two learning process arrived during this experiment. First, we had this learning through play, as François Sigaud explained it in 2009. Play, in the proper senses, is when there is no utility. The pleasure of success is the sole purpose of action. And it was mostly this process, this learning process, which took part during the transmission to the class, to the scholar class, the young people. The shaping-based learning process. And the real game, the real goal was to have fun, actually, to have fun to do the action, even if the action was not really successful. In the contrary, when it was about transmission to young archaeologists, to student in archaeology, it was more a learning process through practice which took place. It was the trial and error learning process. First, the young archaeologists observed. They just observed how the skilled person did. Then they tried. They tried, and mostly they failed. At this moment, they tried to have some advices, and actually, the more skilled person was very available and decided to give advice on how to use the tools, how to position the body, how to use it to don't hurt the body and to be the most efficient. And it was very interesting to try to understand the process of learning that took place during this experiment at this moment. The second case study that I wanted to share with you, and of course I will be very happy to discuss about that after, is about questioning the archaeological hypothesis proposed by technological study. And this is, I think, a real interest, one of the most interest of the experimental approach in our discipline. I would like to take the example of this kind of remains, which is quite extraordinary, because it is the remains of a wall built in earth with a double wooden facing, as we saw just before. It was discovered at Petrocaravellovo tel site. When I studied first this technique, I start by making a comparison, an analogy with another technique that I that we know for earthen construction, especially the pisé, which is a slightly damped earth compacted between wooden formworks. So at this moment, I start to think that the wooden facing could be some kind of wooden formworks, but without removing them after the construction. But in this idea, the earthen part of the wall took a structural part, a structural load-bearing function. In this way, I decided to do a first test. It is not really a protocol-based experiment for this part of the program. It was a test to try our first idea about how to to build with these techniques. So we decided to do this double-facing wall, as you can see on the screen, and we put the wood using rope, only rope to make the joinery, and we put the earth in between the two facings, and we compact the earth just by stepping on the edge of the wall. At the end, we plastered it as I imagine it, I reconstructed by the archaeological evidence on the site. Just to explain the process that we followed, because we experiment all the steps of the chaîne opératoire. So we continued by finishing to build the walls, and after we build the roof frame, we cover it and we burnt it to obtain a burnt building earth fragment referential experimental one to compare it with the archaeological evidences. So after having dismantled the building, I start to study the fragments, the experimental fragment, as I did for the archaeological ones. After having the results, I made the comparison with archaeological fragments to try to understand if our understanding of the archaeological fragments was something was correct, actually, if our technological hypothesis was correct or was one of the true possibilities to build according to the experiment. And if for the three other walls, as you see, all the walls had different techniques to be built, the three other walls, the experiment quite demonstrates that we have something like right about the technical idea to build them. But for the fourth wall, the one with the double facing, the experimental data obtained did not correspond to the archaeological hypothesis, notably because this technique process produced successive layers of compact earth that are not observed in the field. And it was something that was very interesting for us, because as a negative results, we can say that they didn't do it like that. So the using of formworks actually is not the good idea to be taken into account, and we have to think about another way, another reconstruction. In this way, I turn myself to ethnographic comparison in the Balkans, and a very similar technique still appears to be in use, which does not involve compacting the earth. In this case, it is also the wooden frame which is load-bearing, as for the other walls in water or in joint posts. Finally, the study of the collapsed experimental fragments also revealed another possible bias in archaeological technological studies. The absence of reconstruction of these double-facing techniques could be due to the similarity between the fragments resulting from the collapse of the wall built with the wooden frame, this wooden frame, and those built with a water structure. Most of the fragments of the experimental wall were on their surfaces this kind of imprints, vertical one and some small round roads imprints, which are actually, when we find this kind of fragments on the field, we actually often propose water frame reconstruction, because it is very similar to what we understand about this kind of fragments. In order to conclude, the study of the study of Neolithic wood construction techniques in the Balkans revealed the remarkable ingenuity of prehistoric societies. Techniques such as mortise and tenon joints, bridle joints, and pegging testify to an advanced mastery of woodworking techniques and a thorough understanding of the properties of the material available. Archaeological discoveries in this region demonstrate the importance of wood as an essential resource from both a technical, social, and economic point of view. More, what I wanted to share with you is how I see the experimental approach as a way to go further in our technical study, technical archaeological study. It is possible to approach the transmission of the technical skills, especially the use of experimentation and ethnoarchaeological analogy allows us for the formulation of new hypotheses or avenues of inquiry. But of course, I'm not saying that the data obtained through these approaches can be directly applied on the ancient societies, but it is a way to propose some hypotheses about this kind of social aspect of the woodworking during the 5th millennium or during the Neolithic in the Balkans. Thank you very much for your attention.
Thank you very much, Paul. All this applause. I will invite immediately our audience to address their remarks or questions, which I'm sure will be many.
If I may, I have a question, Paul. Thank you so much for your very, very interesting work, especially for us architects that have no idea how long these traditional procedures go so way back. So I want to ask a personal question, actually. Well, because we see all those similarities, especially those constructions that we still see, those filled with earth and mud plaster, and we notice striking similarities with traditional Balkan architecture. So I want to ask if there was something that genuinely surprised you. I mean, most of the things surprised us now that we saw, if we are talking for thousands of years ago. But I want to ask for that one thing that probably surprised you during your work, or you saw something and you said, "This is not possible."
Thank you very much for your question, and I'm thinking a little bit, because I have several points that I could say. It depends of what kind of what point of view I want to take. If I want to speak about the species or techniques or the tools even. But I would go with this idea of the tools used for making the wood. If I want to say what surprised me the most was actually how it was not so difficult to prepare the wood when we were using stone tools. It is, I think, something that is surprised me a lot, because this is maybe the thing which was the further for me, because it is something that I never did, of course, to use stone tools and or even wooden tools. And it was to see how someone, for example, the two persons that I put on my slides, how someone who works with stone tools for 20 years now, he's able to go so precise and to be so I don't know, unlimited to work with this kind of tools. Maybe we can say now that it is normal or logical, okay, now that I did it. But it is really something that at this moment was very impressed for me. And when we are talking with this person, which is called who is called Philippe Guillonnet, he really told me that for him there is no limit for him to do the architectural component in wood for him with this kind of tools. And this was something that it was very surprising, especially because it means that we can go very far for the assemblies and for the joinery, which is something that sometimes for the Neolithic we reduce it to just a natural fork with a round log in between the two branches. And now, of course, we have now archaeological evidence, and I used the whales example because it is something exceptional for the early Neolithic. But now we have really I am very convinced, let's say, that we have no technological limit with this kind of tool to go very far in the shaping of the assembly and of the wood for this period.
Thank you, Paul. Thank you very much. It is very interesting still, your all the work that you have done.
Thank you very much.
If I continue the question of Katerina and your reply, Paul, if the complexity of the assemblages is not a problem for the Neolithics, could we say that the dimension of woods is more a problem? And what are the limits in this case? What should impress us more? A very nice assemblage of pieces, or a very big plank beams?
Thank you very much, Zoe. I would say that for the first part of the question, the dimension of the tree is not a problem. It's not a limit. There is no limit about what kind of tree we want to cut with this kind of tool. Especially we know it by log boat. Actually, when we see some log boat with almost, with 1 meter diameter for the Mesolithic, actually, in the Mesolithic and for the Neolithic period. So we know that if they needed to cut a quite exceptional tree, it was possible for let's say one single event or one single need that they had. But if we go in the construction logic at this time, I think it is a bit different, because when we see this kind of construction, and you know it better than me in Dialogues, we have a lot of trees, a lot of wood actually, and sometimes we reduced a little bit when we speak about construction the acquisition steps. For earth and for wood, and the acquisition of wood is something that when we see for the experiment, and I add a lot of bibliographical data, when we exceed this 15 centimeters diameter, the time for cutting, for felling it, are actually uncertain. Sometimes we are quite low, sometimes a bit higher. So I think that, but maybe it is a bias of our condition. Of course, we are not Neolithic guys, but I think that when we exceed this 15 centimeter diameter, we are less anticipated what will happen. And in this way, in the construction, I would say that it seems that we are mostly staying on something or around 15 centimeter, maybe 20, but not really more, except for some really precise pieces.
Thank you, Paul. I think that there is someone who wants to ask a question. Eustathius, maybe.
Hello.
Hello,
Hello.
Eustathius is our a graduate student is an architect. Today he is in Sweden for his master's degree.
Yeah, irrelevant field for compared to archaeology, but yeah, still interested. And thanks to Miss Rijuli for the invitation. And thanks also, Paul, for the nice presentation. As an architect, I would like to ask you, like, you described before the ingenuity of those, how like refined structures could be made with such primal tools. And I wanted to ask you, like, your opinion on how could we like take as an example the modern architects, maybe technicians, or of this kind of mentality and ingenuity of those people, and in order to apply to the present. I mean, if there are some teachings that you figured out that could be find application in our era, maybe nowadays.
I'm not really sure that I understand really what you mean. Sorry. Is it possible to?
I mean, all you described before, like how they use tools efficiently and with very nice results. And in terms of their mentality, mostly, like if you have drawn some conclusions about the mentality of those people, and if this kind of mentality could find application today, and like to be taught somehow by those people.
Thank you very much. It's not very simple, actually. What can I try to say about the mentality about these people? I don't know if we can really. Actually, I'm not sure that I am far enough in my way to think to answer very clearly and very actually to be very interesting in my answer. But I would say that one great way to study it, to try to approach it, could be to use the ethno-archaeological method and to try to go and to observe, to make a real survey on people of today who are using such kind of techniques, maybe using having a firstly a very exterior point of view, to just observe how they discussed on a settlement of construction settlement, for example, how the social interaction took places. And in a second time, I would maybe go to ask question to and because when we start to ask question in this kind of context, we start to interfere actually, and to give ideas that were not maybe first in the mind of the builders, and to try how with this question, and how when they start to understand what is my interrogation, how they can explain it to me, and how the social interaction continues after that. I don't know if I answer really clearly to your question. I'm sorry, but it is mostly something like a methodological way to think, because I don't have an answer to give now.
Yes, no, it's like it was a broad question. I mean, I didn't want to be like very specific, since I know that your background is not architectural, and yeah, maybe the question was a bit challenging, but yeah, I'm totally satisfied. Thank you.
Thank you very much.
I think we have a question in the chat box, the chat space. Zoe, if you want to have a look.
Yes, so it comes from Yanis Soukandos, who says, congratulations, fantastic, spectacular work. It's very interesting to see the evolution and use of these building techniques through the Bronze Age also. Just a small question, through your study, did you notice how far to the south or east we detect these building techniques? How far of that period we see this? Fantastic work again.
Thank you, Yanni. Actually, if we are speaking about the
hello,
general
Phile.
building...
Hello. You hear me?
Hello.
Fantastic work.
Thank you very much.
Just to make a remark, I ask about how far, as an expansion of you understand the technique you find. Okay.
Yeah, and if you just can say about, do you speak about the double facing techniques especially, or the dome techniques more special, more general?
I want an answer also to the general and the specific, if you can, and if you know it, of course, and you can.
Actually, for the dope technique in general, if we take as a Neolithic from the 7th millennium BC, we know this technique, and I say 7 because I stay in the Aegean Balkan period, because if we go further to the east, of course, we will go more older. It will be.
I mean, did you find it anywhere to the western Thrace, to the western part of Thrace?
Okay. Yes, actually, we have some information about that within Thrace, I think. I can check, but I'm quite sure. And if we are speaking about double facing exactly, we have an example at Ilipinar in Turkey, which is, I think, a little bit older. I'm not sure exactly of the date now, but it is older. I think it's during the sixth millennium at this place that we have this double facing that Rudenberg called sandwich construction in the publication at this part. At Petco Caravellovo, actually, the excavation leading by Alexander Chokojev, we continue to work on this question, on these techniques, and actually the last excavation session in last September was an amazing one for these techniques, because we were on unburnt horizon. And we had some new results and new, I don't know if we can already say results, but new material to think about and to continue our process about this kind of construction and how it was used and why it was used. And if we go further, because I didn't make the bibliographical work for the Western Europe, but it seems that we have an example in France also for I think it's final Neolithic. So it is very interesting because I'm starting really to think that we have a difficulty to identify this technique on the site, more than thinking that it is something very exceptional on some sites, few sites.
Okay, thank you, Paul. Just one more question, if I may, a provocative one. Did you make some observations about the Bronze Age?
Sorry, on Bronze Age, sorry?
Yeah, if you had the time to make some observations about the evolution of this technique during the Bronze Age, I mean, if you see some differences.
Unfortunately, for the double facing, for the moment, I don't have any answer to give you.
Okay.
I didn't see something like that, but I didn't make studies as much deeper that I did for the Neolithic, and for the moment. And but for dope techniques, general dope techniques, we have for the Bronze Age some information of these techniques, and I don't know, especially for early Bronze Age in this region, for the north of Greece, we know the waterland dope construction. I can take Dikylitas as an example for the early Bronze Age, and but also for the late Bronze Age, actually, maybe not for the main wall of the building, but we know in the sector 7 at Dikylitas, for example, a beautiful partition wall in clay, in dope, sorry. So yeah, we have some information about that, and in Bulgaria we have plenty of example for dope techniques.
Yeah. Okay, Paul. Thank you very much. Congratulations again, my friend. Congratulations.
Thank you.
May I, or we are out of time?
No, please.
Okay. I wanted to ask another question, a personal one. Since like a major part of your research, as I understood well, is the local materials, the local vegetation of the Balkans, Southern Balkans. I wanted to ask you, like, what's your connection with this geographic area, or if you have like experiences, or I don't know, maybe family connection, or anyhow, like what inspired you to get involved in this like specific geographical area.
To answer the question, actually, no, I don't have any relation or relative in this area, or actually, I didn't at this moment. I didn't have any relation. Now, since I'm working there for 10 years, I have some close friends now there, but why I started to work there, it is actually because I was interested in wooden techniques. And once I spoke with Zoe Tirtsoni about the Hotnica tell site, and I quite very quickly fell in love of these wooden floors, and after of the region. But at the beginning, I didn't have any personal interest in this region. But the archaeological material is quite impressive.
Thank you. Very interesting.
The heartbeat came from the wooden floor of Hotnica. Great. I don't know if there are any more questions or from people who are not familiar eventually with your works. Apparently not. So I would like to remind you that we are only in the middle of this cycle of lectures, the second series of these lectures, but we are going to stop here for the year, for the civil year 2025. And we will see each other again in the middle of January. Our next conference is on 12 of January with Professor Palivou. Claire Palivou, and we are in advance very thrilled to have her in this panel. So I hope that we will see you all in next year. If in the meantime you have questions or remarks to address to any of the speakers or to the organizers, you can write to Katerina or me, or directly to Paul Bacoup and Hara Procopiou, who was our first speaker. And that's all.
Thank you very much for everybody for being here with us tonight. So we will see you next year, next time. And thank you, Paul.
Thank you again for the invitation. Have a good evening.